Dart Skill presents Number Patterns. When a set of numbers are related by a common rule that relates each number to its previous number on the set, we have a sequence. Consider the set of numbers 5, 8, 11, 14, 17, 20, and so on. If you look at any number on this set of numbers after the first number, you will find out that every number is exactly 3 more than the previous number. 8 is 3 more than 5. You add 3 to 8, you get 11. You add another 3, you get 14. You add another 3, you get 17, and so on. So we could say the common rule that binds all these numbers together is add 3. And the actual numbers are called the terms of the sequence. So all these numbers taken together in the same order form the sequence, and then we have the individual terms on the sequence. We say 5 is the first term of the sequence, 8 is the second term, 11 is the third term, and so on. And given the rule and the first term on any sequence, you can pretty much generate all the other numbers on the sequence. For example, if I told you that the first term, often denoted by the letter T1, T for term and subscript 1 for the first term, is equal to, let's say, 8, and the rule is add 7. So we have the first term of the sequence as 8. The second term is 7 more than 8, which is 15. The third term is 7 more than 15, which is 22. So you pretty much keep adding 7 to each term to get the next one. So we have 29, 36, and so on. Let's do another one. Let's say the first term on a sequence is 3, and the rule this time is multiply by negative 2. So we have the first term as 3, the second term is 3 multiplied with negative 2, that becomes negative 6. The third term is negative 6, which is the second term multiplied with negative 2, and that becomes a positive 12. And the fourth term is 12, or positive 12 times negative 2, which is negative 24. And then the fifth term is 48, negative 24 times negative 2, and so on. So as you can see, this particular sequence has got alternating positive and negative terms. And that's perfectly alright. There's a common rule that binds each of the terms, or one term with the previous term. Sometimes the rule can also be given as a formula in place of writing down it in plain words. Consider a sequence in which the first term is, let's say, 5, and the rule is given as Tn is equal to n squared plus 4. Now what this means is, n is a variable, it keeps changing, so you could have T1, T2, T3, T4, and so on. And when you plug in a certain number for n, for example T1, when n is equal to 1, you have the value of the first term is equal to 1 square, plug in the same value of n in the formula, so you have 1 square plus 4. And 1 square plus 4 is nothing but 5. So T1 is 5. And then we can generate the other terms in the sequence by using this formula. We have the first term as 5. It's already given. In any case, we could have also figured that out from this formula. Now how about T2? T2 is nothing but plug in 2 in place of n in this formula. So it becomes 2 squared plus 4. 2 squared is 4. 4 plus 4 is 8. So the second term is 8. How about T3? T3 is 3 squared plus 4. That's n squared plus 4. N is 3. So 3 squared is 9. 9 plus 4 is 13. So the third term is 13. And T4 similarly is 4 square plus 4, which is 16 plus 4, which is 20. And T5 is 5 square plus 4. That's 25 plus 4, which is 29, and so on. Note that we are neither adding nor subtracting, nor multiplying, nor dividing any term with a fixed number to get the next term. However, there's still a common rule or a formula that binds these numbers together. So this also is a valid sequence of numbers. And given the value of n, you can find any term in this sequence.